Alright, looking at our next video, we're now looking at 1A.3. And our 1A.3 Mastery Learning Objective says, I can simplify an expression by using the product and quotient rule. Okay. So the big things in this one that we're going to be looking at is product and quotient rules, right? Let's highlight that. And then, so when we have operations with variables, we have to be very careful. Addition, when we're adding up x's, the number of x's is the coefficient. So here I have 1, 2, 3, 4, 5 x's. So that's what I write. It is 5x. Okay? And that's because the symbol, the operator between all of those is addition. With multiplication, the number of x's is the exponent. So here I have 1, 2, 3, 4, 5 x's being multiplied. So that's x to the 5th. Okay? So be very careful with adding versus multiplying. So let's look at some examples here of what eventually is going to become our power rule. So if you look at this first example, it says simplify the expression by first expanding it. So we have x squared times x to the 8th. So x squared means x times x. Select things, that's why. X squared. And then x to the 8th means 8 x's. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do the same thing as I did up here. Now you can just count them. How many do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's x to the 10th. Okay, 2z cubed. For 2z cubed, the 2 is not being cubed. The 2 is just the coefficient. So there is just 1, 2, but there should be 3, there's a multiplication there too, 3 z's. Same thing for this, right? There's 1, 4, and 2 z's. So if I have a 2 and a 4, 2 times 4 is 8. Nice and easy. And then how many z's do I have? We have 5. Looking at our third example, x squared y cubed times x cubed y to the 4th. So this x squared y cubed is x times y times y times y. And remember, parentheses is just another way of doing multiplication. So then I'm multiplying right here. And then I have 3 more x's and 4 more y's. I'm going to try and fit them all in. So now I have to be careful. Again, I'm going to write them kind of separately. How many x's do I have? 1, 2, 3, 4, 5. And how many y's do we have? 1, 2, 3, 4, 5, 6, 7. So let's look at what we really did here, right? This is a wonderful way to do it, but what we're going to be dealing with is what we call rational exponents or fraction exponents. And if you look here, I don't know how to write 2/3 of an x or 4/3 of an x. So when we have real numbers, it's easy to expand. But now we need to think about what the rule actually is so we can use it here. Okay? So if I have 2 and an 8 and got 10, what operation did we do? Well, 2 plus 8 equals 10. Let's see if that same rule applies here. These multiplied, then my exponents. I had a 3 and a 2 and I got 5. Yes, 3 plus 2 is 5. Here, I have to be careful because I can only add, right, do exponents with the same base. So the x's get added, 2 and 3, and the y exponents get added to 7. And that is exactly what our power rule says. When multiplying two numbers with the same base, you add the exponents. So a to the m times a to the n is a to the m plus n. So let's look at some examples. Here, we have all the same base, right? So I have x, and then my exponents. This is where you need to be very careful. Do you see how my exponent is not right next to it? It's up and to the right and a little bit smaller. Right? It's harder with the fractions, I know, but be very careful with where you're placing your exponents. Okay, so x to the 2/3 plus 4/3 plus 1/3. If you feel very confident adding fractions, go ahead and add your fractions. Otherwise, you can always pull up your calculator. 2/3. And I just do 4 divided by 3, right, as 4/3. 1 divided by 3 for 1/3. Okay? And we get 7/3. Again, being very careful that that exponent is up a little bit higher than our x so that it looks like an exponent. I'm going to be very picky about where your exponents are in your practice because otherwise it means something completely different. Okay? Alright, go ahead, pause the video and try number 5. We'll go over it in a minute. At this time, you should have an answer for number 5. So let's go over it. My base is y. I have my exponents of 1/2 plus 1/2. And you get y to the, right, 1/2 plus 1/2 is 1. There's one thing here though, I don't have to write that 1. Okay, and it's just like when you don't have a coefficient in front, it's 1. When you don't have an exponent, it's understood to be 1. Technically, if you wrote this on a test, I would not mark it incorrect. But as we are adding exponents, and you'll see it in our next example, we want to make sure we know there is a 1 hidden there. Okay, so it works both ways. Awesome. Let's look at number 6. Oh, again, if you got that one incorrect, you might have missed this. You don't have to do the y part. But if there's something else you're confused on, make sure you ask before moving on. All right, let's look at number 6. F to the 1/4 times g, and then f to the 5/4 times g to the 2/3. Again, remember, there is also multiplication here. Parentheses also mean multiplication. So I'm looking for my same bases. I have an f here and an f here. Okay, so that's f. And what are the exponents on that? 1/4 plus 5/4. And then I'm multiplying that with my g, right? Those have the same base. Now, like I was saying, this has an exponent of 1. You have to be very careful that you remember that that exponent is there. Plus 2/3. So then this is f 1/4 plus 5/4. Again, 1 divided by 4 plus 5 divided by 4. Okay. And that's 3/2. Your answer should be a fraction. If you're using your own calculator and you're getting decimals, raise your hand. We'll come around and help you with how to make it a fraction. Your calculator can give you the fraction, It's just an extra step. If you're using this calculator, it gives it to you right away as a fraction, so that's nice. So G. Okay, these are right next to each other. Okay, sometimes students write them like they're two separate answers. This is one answer. Technically, I could put a multiplication sign in between them, but I don't have to. Okay, a lot of times with kind of how we wrote this x and y up at the top here, right? I don't have to put a multiplication symbol between two different variables, okay? But they do have to be right next to each other. All right, let's look at number 7. 3c to the 2/5 times 2d to the 1/2, 4c to the 3/5 times d to the 1/4. This problem is very similar to number 6, except now it has numbers. All I do is I grab all my numbers and I bring them out in front. Okay? Then do the same thing, right? My base is c. Two-fifths and 3/5. My base is D. 1/2 and 1/4. Oh, forgot to write D down. D. Oh, my board's not liking. Again, this is all written on one line, going straight across. It's like a sentence. I can't break it up and put sentences in random orders. All right, math has grammar rules just like a language does. For sake of time, I'm not going to pop up the calculator, but again, you can always use a calculator. 3 times 2 times 4 is 24. 2/5 plus 3/5 is 1. And then D 1/2 plus 1/4 is 3/4. Again, I would write this as 24C D to the 3/4. Okay? I don't need to have that 1 there. All right, go ahead and try number 8 and number 9. So again, pause your video and try and get those answers. At this time, you should have an answer for number 8 and number 9. You should have paused and gotten that answer. Okay. This is similar to what we did here. I have these numbers out in front, my coefficients. So I'm going to bring them forward. My base is x. My exponents are 4/5 and 2/5. 3 times 2 is 6. X to the 6/5. Again, if you did not get that answer, raise your hand. Make sure you ask questions on anything you're still confused about. Looking at number 9, again, similar. I'm going to bring forward all of my numbers. Then looking for the same bases, I have an A. This A has an exponent of 1, right, and 2. Then I have B, and it has an exponent of 4. When I multiply these out, I get 54, A to the 3rd, B to the 4th. So again, if you tried it on your own and you did not get that, raise your hand, and we'll come around and help you. Otherwise, go ahead and turn to the next page. We're also going to do division. Division is very similar. We're also going to start by expanding our problems first, okay? So here on top, I have x, 1/2 1, 2, 3, 4, 5. 5 x's, and on bottom I have 2 x's. What happens when I have the same thing on top and on bottom? Well, right, these are the same, they go away.
Hi.
These are the same, they go away. Okay, so now I have x to the third. And that's it. Right, because there's 1, 2, 3 of them. Same thing here. I have 4. I should have done that in a different color. Pretend that's red. That's fine. And then over 8, and I have 7 x's. 2, 3, 4, 5, 6, 7. There we go. Okay, so 4 over 8, right? That, if you use a calculator and I divide 4 over 8, I get 1/2. So I'm going to put 1/2. Okay? So I've dealt with those already. Same thing here, x, 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 x. All right, so I can get rid of 3 x's. And if I look, I have 1, 2, 3, 4 x's on the bottom. Okay, so wherever the x's are, that's where they need to stay. Last one. 2 x's on top and 5 y's. 6 x's on bottom and 2 y's. Okay. So now what can I cancel? Well, I have x's and another x. I don't have any more x's, but I have y's. Okay, and now there's nothing else that's the same on top and bottom. I've canceled out all of the things that are the same. So what do I have? I have 3 y's on top and 4 x's on bottom. So now we think about what our rule is. Well, if I do 5 and 2 and get 3, 5 minus 2 is 3. Here, same thing, but it went on bottom. Why? Because our bigger number is on bottom, but still then 7 minus 3 is 4. Same thing here. With our x's, the bigger number is on bottom. 6 minus 2 is 4. With our y's, the bigger number is on top, and 5 minus 2 is 3. Okay? So that is our quotient rule. When dividing two numbers with the same base, subtract the exponents, and the only thing is wherever the bigger number is. Okay. All right, so here we look at our numbers first. So we do have 2 over 2. And then these are both x. This one's bigger. So that's where the x is going to go. And then I do 4 minus 2. 2 over 2 is 1. X, 4 minus 2 is 2. All right, 12 over 4. Then these are the same base. This one's bigger. So that y is going to go on top. And then you have 5 minus 4. For sake of time, I'm not going to pull the calculator out, but 12 divided by 4 is just 3. Y to the first. We don't have to put that 1 though, right? So we can just write 3y. If I put that 1, we can get rid of it. Okay. Number 3, I have multiple bases here. So we have our x's. That's our bigger one. So we do 8 minus 6. Then we have our y's. That's our bigger one. So we have 11 minus 2. When you have nothing in your numerator, you have to put a 1 there. You cannot have an empty numerator. You can have an empty denominator. So this is 1 over x squared y to the 9th. This video is getting longer. So we'll stop there, don't worry about number 4, and go ahead and get started working on your 1A.3 activity.